Welcome back to the lecture series on biochemistry topics. I'm Dr. K. Sujay, Professor of Biochemistry. Let's see the electron transport chain and oxidative phosphorylation for today's topic. Before getting into exactly what is electron transport chain, let us see what are all the mitochondrial shuttles available to shuttle the reducing equivalents produced in various cycles like glycolysis and TCA cycle. Electron transport chain is especially to transfer the electrons from the reducing equivalents like NADH2, FADH2 formed in glycolysis and TCA cycle into the formation of ATP. So this NADH2, which is formed in glycolysis, cannot enter directly into the mitochondria because ETC takes place in mitochondria, but glycolysis takes place in cytoplasm. So this reducing equivalent which is formed in cytoplasm has to enter the mitochondria. So there are certain shuttles to take this reducing equivalence from cytoplasm into the mitochondria. So what are those shuttles? Not only that, the ATP which is formed inside the mitochondrial matrix has to be taken outside to the cytoplasm, and ADP also has to be transported from cytoplasm into the mitochondria. So for this also we have certain shuttle. So this shuttle of ATP-ADP transporter is to transport the ATP from mitochondria into cytoplasm and ADP from cytoplasm into mitochondria. Because mitochondrial membranes are semi-permeable, it cannot permeate the reducing equivalents like NADH2 or FADH2 or ATP or ADP across its membrane. It needs certain proteins like transporters and shuttles. Okay, so this shuttle is called as glycerol phosphate shuttle. This is to transport the NADH2 which is present in the cytosol produced in glycolysis to enter inside the mitochondrial matrix to take part in electron transport chain. So this NADH2 donates the reducing equivalents to dihydroxyacetone phosphate to form glycerol 3-phosphate. This glycerol 3-phosphate is now capable of entering into mitochondrial matrix, donates the reducing equivalents back to FAD. Instead of NAD inside the matrix, it is donated to FAD. So here FADH2 is formed instead of NADH2. So FADH2 now can participate in electron transport chain. It transports its electrons to various redox potential in electron transport chains, finally to produce water. In this series, 1.5 ATP will be produced as a result of electron transport chain. So this, after donating the reducing equivalents, it converts back to dihydroxyacetone phosphate. This gets back into the cytosol. So this is a shuttle, DHAP to glycerol 3-phosphate and glycerol 3-phosphate again to DHAP, and this is a shuttle mechanism. So why is this taking place? To take NADH2 to take only the reducing equivalents from outside into the matrix. Okay, so what is the disadvantage in this shuttle is that if NADH2 would have formed again back to NADH2 inside the matrix, we would have got 2.5 ATP instead of 1.5. But here there is loss of ATP because FADH2 will not completely take part in ETC by all the complexes. It will one complex will not donate protons. I will explain you later on. So it will be donating only 1.5 ATPs. There is one more shuttle called as malate aspartate shuttle. So you can see here. So it is the oxaloacetate carries the reducing equivalents from NADH2 which is present in cytosol. This NADH2 also is formed from the glycolysis. So this NADH2 donates the reducing equivalents to malate. So this malate is now permeable to the mitochondrial membrane. So it enters into the mitochondria. It gets back again into oxaloacetate. While this donates the malate donates this reducing equivalents back to NAD inside. So here in this shuttle, if you see, the NADH is converted back to NADH. So this later on will be taking part in an electron transport chain